Here's another linear graph which we're going to draw. I've just changed this one. I was going to have 2/3, but I thought, well, I got a 3 on the end, so I'm going to go 5 instead. Just change it up a little bit. All right. So how do we draw that? Now, for an exam, we can just draw this very, very easily. If we're just going to sketch this, we can say the y-intercept is -3, the gradient is going 5 along, -2, 5 along, 2 down, 5 along, 2 down. Nice and simple. But for an exam, I would suggest we don't do that. For an exam, we want to actually state when x is 0, y will equal -2/5 times 0 minus 3, y is -3. Therefore, y-intercept equals a 0 there, comma, -3. 0 along, -3. We also then want to do the same for the y-intercept. Sorry, I beg your pardon. The x-intercept, so we want to say when y equals 0, 0 is equal to -2/5 x minus 3. Then we're going to add 3 to both sides, yeah? Add 3 to both sides. So now this disappears, and we're going to have, I'll write this on the way down. So -2/5 x is equal to 3. I'm going to multiply both sides by 5, multiply this by 5, multiply this by 5, and of course those 5s now disappear. I've got -2x is equal to 3 5s is 15. I'm going to divide both sides by -2, -2. And x will equal half of 15, so -7.5 or 7.5. Or you could leave it -15, 15 on -2 if you like. Although -7.5 for me just means a whole lot more. So now we're going to say x-intercept equals, and we've got an x value of -7.5, comma, and we've got the y, which is 0. So you want to express these things here as ordered pairs. Now we can go ahead and we can put that on the graph. Here is our graph. So here it is. Just sketch nicely y, 0, and x. So the y is 0 along, 3 up. So I'll put 1, 2, 3. Oh, wait, -3. I almost got caught out. So easy to do. 1, 2, 3. There's my -3. So that is my y-intercept. My next x-intercept is -7.5, comma, 0. -7.5. All right, so I'm going to go 1, 2, 3, 4, 5, 6, 7. There's my 8 there. 7.5 is going to be right in between there like that. And I'm going to just link those two up and see if I can do it reasonably convincingly. Okay, well, that's kind of all right. And then on that line somewhere, we would want to write the equation, which is y is equal to -2/5 x minus 3. And that would be, and I'll put, again, arrows everywhere, because these are not line segments. These are lines, continuous lines. So that would be the way which I would draw that. Now, important to label everything. So put a 0 here, an x and a y. Label the points. So I've got an 8 here, but I actually want to label the points. This is going to be -7.5, comma 0. So here it is, -7.5, comma 0. And over here we've got 0 along, comma, -3. And that is how we would draw the graph. And I think the equations here, do little things like keeping the equals under each other as best you can would be good. Not that one there, although that's really not part of the equation, really. This is part of the same equation. These are all part of the same equation. This is part of a different, this is separate, really. But make sure you do the little things, in other words, do count in terms of the marks you're likely to get. All right. By the way, for any of the exams which you do, for many schools now, you need to put a conclusion sort of statement saying, this is what I found. And this, in other words, this is the result of whatever it was you were measuring. Now, in this case, there's no context to this. It just says, draw this graph. But let's say this graph represented something. Let's say it represented the cost of groceries at the supermarket, and this was, say, the decreasing price or something like that, or the way your dollar was getting less value as inflation increased, you would need to have a statement that said that. And you would need to show how the line you had drawn represented the thing that you were in fact addressing in the question. So just be aware of that. A statement in context usually will be required.